stoichiometry given precipitation reactions. Okay, so we're just going to go straight to the problem. Calculate the mass of solid sodium chloride that must be added to 1.5 liters of a 0.1 molar lead-2 nitrate solution to precipitate all the lead-2 ions in the form of lead-2 chloride. So this is a way of removing all of the lead-2 toxic ion out of a solution. And then environmental hazard disposal can deal with the solid. So a scenario like this could very well be used to decontaminate a solution, in that once you have precipitated all of the lead-2 ions out, then you've got a solid that you can deal with and dump the rest of the solution down the drain. All right, so this is a stoichiometry problem, so the very first thing that we're going to need for this is a balanced equation. So we've got some sodium chloride that's going to react with lead-2 nitrate. So the first thing I want to do is I want to write a balanced equation. So I have got lead-2 nitrate in its solution, so it's aqueous, and we're going to add some sodium chloride. Now, it says solid sodium chloride, but as soon as we add it to this, it's going to become what? It's going to become aqueous. Okay, and this is a double replacement. It's a precipitation reaction. So the cations are going to change places. We're going to get some sodium nitrate and we are going to get some lead-2, right, because these things are just switching. Cations are switching their anions. So sodium nitrate and lead-2 chloride. So the first thing we want to do here before I assign any phases is let's go ahead and balance this equation. So we're going to have 2 and I need to move this plus sign over a little bit. And we're going to have a 2. There we go. Now, based on solubility rules, we know that this is going to be aqueous. Not only do we have a nitrate here, but we also have a group 1 metal. They are always soluble. So this is going to be AQ, and actually it tells us in the problem that this is going to be our precipitate, that we're trying to precipitate out the lead ion, and we're going to get this product. So this is our solvent. All right, so great. There we go. We've got our balanced equation, and because we're doing stoichiometry, that's as far as we need to go. Because what we're looking for here is a mole ratio, actually between these two things. All right, so if we go to the problem, we've got 0.1 molar lead-2 nitrate. So we're going to start with that. We have 0.100 moles of lead-2 nitrate per liter. And how many liters of lead-2 nitrate do we have? We have 1.5 liters of it. So 1.50 liters of PbNO3 2. I'm afraid I'm going to run Okay, so our liters of lead 2 nitrate are going to cancel, leaving us moles. All right, now the question is asking us for the grams mass of sodium chloride that's needed to precipitate out all of the lead 2 ions. So the next thing we're going to do is we're going to utilize a mole ratio. So for every mole of lead 2 nitrate, how many moles of NaCl are necessary? So we're going to go to our balanced equation. For every 1, we need 2. 1 to 2. 1 to 2. Our moles cancel. And we are not looking for moles of sodium chloride, we are looking for the mass of sodium chloride. And so we're going to utilize its molar mass, which is 58.45. Oh, this isn't going to work, is it? Grams per mole. I'm going to change the color of my pen. So 58.45 grams of NaCl per mole of NaCl. Our moles will cancel, leaving us with the amount of grams it takes to precipitate out all the lead 2 ions from a lead 2 nitrate solution. So much of this is a review, right? We're just doing stoichiometry. The new thing that we have added to our stoichiometry is the idea of molarity. So moles per liter, we've got our volume, and that's our new twist on the stoichiometry. So you guys do this calculation, and we'll look for this answer tomorrow in class.